So first, the introduction. And I haven't given this in a while. For a while, once I had it really down to a science, but I'll give you the general idea and you can tailor it. Materials. Materials are integral to human society. I mean, if you think about it, we even talk about our social evolution in terms of materials. We had the Stone Age and the Bronze Age and the Iron Age, and now maybe we're living in the Silicon Age, or maybe it's the Polymer Age. I don't know. Future historians can bicker about that, but materials are about who we are as a people. It tells us and gives us criteria, constraints about how we interact with each other, how we go to work, how we raise our families. Everything about our existence is determined by the materials around us. And it makes sense because everything is a material. Everything in this room is a material, and what's more important, that you probably don't even think about, is that everything was designed by a materials engineer. The light bulbs, there's a little metal flange. A materials engineer designed that metal and selected that metal for this light bulb because it was needed for that application. The dry erase board, the polymer, materials engineering. The paint on the wall. Paint is a material, and you would be amazed at how significant paint is. I got a friend who works for John Deere. They have a whole laboratory of materials people that study paint. So John Deere, they got that green, and they've got a kind of a gold color. You have to make the paint, it has to be the right color. It has to be resistant to fading. It has to stick well. It has to be corrosion resistant. So as they're developing paints that are better, they'll paint these on metals, and then they send them down to the southern tip of Florida, and they let them sit for years. And the storms come in, they blow sand and salt, and they come back 2 years later, and they look at how well it survived. Paint is a material, and you don't even think about it. You just go to the store and buy it. But there is someone designing that material. I chose to be a materials engineer when I went to college because I realized that whatever I studied, I was going to be a materials engineer. If you think about it, right? Why don't we have a space plane, right? A plane that can take off, fly into space, and land. We have dozens of designs, but no space plane, because we don't have the materials to make it work. Why don't we mine metals from our landfills? We have landfills all over the country. They're full of gold and other precious metals, rare earth materials, but they just sit there. And that's because we don't have the technology to dig through that and separate out the precious elements from the waste and the toxic elements in an affordable fashion. Our being able to recycle our waste is a materials problem. And that's about separating the useful from the unuseful. But separations, that's also part of chemical engineering, right? Separations, you think, why are pharmaceuticals so expensive? There are drugs, you get a shot, it costs you $65,000 a piece. Well, that's because they can synthesize these drugs, but then they have the waste product and they have the actual drug, and they have to manually separate them. There's no easy way to separate what you want from the waste. So chemical engineering, that is about materials, or at least cutting edge work. What about catalysis? That's also part of chemical engineering, right? We would really like to take water, separate water into hydrogen and oxygen, and then put that hydrogen to make a fuel cell to power electric vehicles. And then the hydrogen would go through and it would recombine with the oxygen in the air, and we'd have a vehicle that just runs on water. Why don't we do that? Because we don't have a material that will let us effectively store the hydrogen, because we have to store it in the idea is to store it in some type of solid that allows us to compress a bunch of hydrogen and store it safely. We don't have a cheap way to separate the oxygen from the hydrogen, because that's about catalysis. And right now, all the catalytic methods we have, the materials, it takes more energy to separate than it's worth. So if we had a better catalytic material, we could have water-powered vehicles. Nuclear energy. Right now, there are 100,000 tons of nuclear waste being stored all across the US. And they're being stored on site in these big barrels, and they're being contained. We have nowhere to put it, right? And what we need to do is we need to find some way to encapsulate that waste, and we're trying to do this in the form of glass, so that we can have a glass rod. It's going to be a barrel size, and we can bury it for the next 20,000 years, and it's going to be stable. It's a major problem, but we know that nuclear energy is necessary. If we look at the rate of human growth, and we look at our concern about the environmental damage of using fossil fuels, nuclear is the only way that we can continue to increase our energy consumption while decreasing our impact on the environment. But in order for us to make this viable, we have to have an intelligent and safe way to deal with the waste. Your cell phone. Your cell phone is a modern miracle in terms of the materials engineering that goes into this. But there's still a lot that can be done. Did you know that 90% of the weight of your phone is the battery, and most of that is cobalt? It's one of the electrodes, cobalt oxide. Now, cobalt, it's found all over the world, but most of our cobalt that we use in our phones comes from a region of Africa that's experiencing a civil war, and the reason it comes from there is because the people are allowed to dig it out and just dump the waste in the ground. And you say, well, we should be mining cobalt in the US. And we have deposits. But we can't mine the cobalt in an environmentally safe manner. We don't want to contaminate our groundwater, so it's cheaper to get it from somewhere that we don't care about. Materials engineering is about designing processing techniques that will let us extract metals from the ground in a way that's environmentally safe. We want to have technologies that are sustainable, and clearly dumping waste in the ground is not long-term sustainable. And certainly going to war-torn regions is not sustainable. We need better materials, or even better material processing, that allow us to make technologies in a responsible fashion. Aerospace, that's a big thing, especially here in Washington, right? We have all of these companies that are building rockets, and they're building capsules. But you think about it, why is it that hard? I mean, we know how rocket propulsion works. We know all the mathematics for shooting something up. It's because we're trying to make rockets that are safe, clean, and effective. What's limiting the development of all of this is materials technology. Materials engineers are front and center in our goals to go out, explore space, colonize space. And if you remember, there was the launch of Elon Musk's spaceman, right? He had a little the Tesla. Well, if you remember watching that, the lead presenter in their video broadcast, that was a materials engineer. Materials engineers are all through this technology and all through this industry. It's not just outer space. Aerospace is also domestic travel, and companies like Boeing are constantly improving their materials. The Dreamliner, I'm sure you've heard of this, this big, massive jumbo jet. It's mostly a composite. And what that means, from a kind of a coarse explanation, is it's mostly glue that's holding together, little bits of fiber. So when you get on one of these and you fly, to China or, some long distance, you're basically flying on an airplane that's wings are nothing but glue. Glue is a material. Oh, glue is an amazing material. It's an amazingly challenging material because you need a glue that will stick where it should and not stick where it shouldn't, be curable, be not curable, interact with sunlight, not interact with sunlight, hold paint. It has all of these properties. And someone had to design that. And there's new composites that are being made and new materials challenges that require materials engineers. So materials are everywhere, and I chose to go to college at WSU, sell it, at WSU because I recognized that if I was doing good work that was going to impact the world around me, I was going to be a materials engineer, so I wanted my degree to reflect the work I'm going to be doing.